All right, this is 129S, and we're down here to the book chapter about cross-site scripting. We've already done some hands-on labs about cross-site scripting. It's a big topic. So, here's the slides. All right. So now, if cross-site scripting, you send some script code to a server, do something like put it on a Facebook page or something, and then somebody views that page, and they now run script that an attacker put on the page instead of the website developer putting it on the page. So you have the ability to add script to a page that will be viewed in somebody's browser. Now what can you do? Well, you can steal the cookies assigned to that domain in the browser, and if the browser has a vulnerability that lets you escape from the browser's security sandbox and execute commands on the host, you might be able to install malware or do other things, put on a keylogger and so on. It's extremely common to have cross-site scripting vulnerabilities. It's easy to make this mistake, and it happens a lot, like we said before. I've seen estimates like 80% of all websites have cross-site scripting. I don't know if it's that bad, but it's really bad. So there's the three main types. Reflected cross-site scripting is the simplest one, where you have some place where you can type in data, like in a search engine, and the next page says searching for, you type in shoes, and it says searching for shoes, and you get to put HTML tags in there, and it executes it. So I've got a simple example of that here. See how I make this bigger? Yeah, all right. So here's the simple one. If I type in hi, the next page just says hi. It puts it in what's called an error message. So it just takes data from the user, and so if I put in script alert /script, then it'll run that and pop up a box. So this is script running on the page that was not put up by the developer of this page, but was entered in as data into this page, so you're able to bounce an attack off the server and back to you. That's called reflected cross-site scripting. It's probably the most common type, and people tend to regard it as the least severe type because on the surface it appears like all you can do is attack yourself. You can run code in your own browser, which of course doesn't seem like much of a problem at all, but what you do is you construct a URL that includes that data, and then you send it to a third party. So you would catch this request with burp that sends it with this data, and then send that to someone else. For example, if it does put it up here in the URL bar, let's see if it does. And it does, good. So notice this URL bar. I can copy this whole thing, and let me paste it into a text editor so you can see it. All right, so now I have a URL which opens the page, and it includes this message, and here's the script alert, all that jazz. So now all I have to do is send this whole link to somebody and get them to click on it. And now their browser will run this script that came from me. And if this looks too fishy, I can run it through a URL shortener or some other trick so it's not obvious that this is a funny looking link. If you think anybody would notice, most users would not notice. Anyway, so that's how you attack somebody with reflected cross-site scripting. You send them a URL, which appears to go to some innocent place like Google, but in fact it has extra script that the Google developers did not put there, and now this person is running that website with extra script added by the attacker. So, like say the user might log in and have a cookie, and then if I can trick them into running a website that contains data that's like script send the cookie to a third party, then when they open that link, they will send me their session cookie, and now I can log in as them. All right. And on it goes. All right. So this is, if you have a persistent cookie, if you have Remember Me, then even if you're not currently logged in, your browser will still have that cookie. And so that cookie will still let me in. And as I talked about before, something like half the websites I tested a few years ago had the property that even if you change your password, the old cookies continue to work as authentication cookies. So once somebody's in your account, there is no way to get them out at all, except to cancel the account and make a new one. All right, now if I try to get your cookies from a different domain, I can't get it. Your browser has, yes, they're just not expiring cookies, exactly. So now if I'm a domain called evil.com, and I control what's on that page, and I get you to go to that page, I can steal cookies, but only cookies for evil.com. Your browser has the same origin policy, so it will only send cookies to a domain in the same domain as the origin of the domain that set the cookie. So I wouldn't be able to steal your target cookies from the domain evil.com. But if I do cross-site scripting, I can send you to target.com with extra script from me, which your browser will think came from that server, and now I can steal data which your browser thought it was only sending to the authorized recipient. That's why they call it cross-site scripting. I take a script that did not come from target.com, and I trick your browser into running it as if it came from target.com. So, stored cross-site scripting is where you store a message in a chat room or something, and then anybody that views that page will see it. This way I can make one upload and it will attack a large number of users. And in a way, it's not even fake. It really is coming from that server, right? I'm not bouncing it in the URL. It's actually, I can put data on like Facebook. The whole point of Facebook, right, is I can post a message and other people can see it. But if they make a mistake of letting me put script tags in there, I can put up a script and everybody can see that and it will run in their browser. So that's easy enough to do. You just put up a comment with a script, and when you view it, it'll pop up. So that's stored cross-site scripting. I post a message with a script, and now other people, when they view that page later, they request the page, they see the page, now my code runs on their machine and it does whatever evil thing I want to do. Most commonly steal their session cookie, but perhaps other things, like exploit a browser vulnerability and install malware on their machine, or something like that. And then there's document object model, baked XSS, which is just a variation on stored cross-site scripting. The point is where you put in data, but the data does not directly explicitly appear on the page. It appears in some less obvious way on the page, like inside an image tag or something. So I would, you'd send a request, you'd get a response, and you put in some data on the page in this request, and that data is used to create part of the page here. How you get that onto the page? You mean this one here? Let me bring up the demo. Oh, how do you get that into the DOM? Right, well, I'll show you that. Right, we'll get that. All right, so yeah, it works like this. You have client-side app JavaScript, which your developer may choose, rather than the document object model is. Remember, I was confused about this first. Let me start with the demonstration. That's probably the best way to do this. The document object model one is number 4. So let me bring up my number 4 here. Okay, let's talk about it. Okay, this is DOM based. So here I have a URL that has a message equals hi. Okay, so when you render that, it has the message hi here. Now it could have just taken this parameter and put it there, but it didn't. It did it this way. It calculated that parameter. So let me view the entire source of this. There we are, view page source, and zoom this up. Okay, here's what's going on. I have a field here called message. And here in my script, here I write the message. So the message is calculated by going to the URL up here and finding the thing that comes after message equal. So instead of just this being a parameter, oh yeah, I've tried inspect. Inspect never shows me enough. Anyway, so I have here I've got this data hi, and this is called document object model, where you refer to it by finding it in some way and put it in a certain place on the page. Yeah, the inspect is probably useful in a big page. But this is the point. It amounts to essentially the same thing as the other kinds of cross-site scripting, but it works through JavaScript. And this is called the document object model, where you pick part of a page, calculating it. Like here's the URL index of message. That will go into the URL and pick out the part of it that comes after message equal. So you do some kind of calculation to pick part of the input data from the user and then put it on the page. That's all. The reason why it matters is because it may be a little more tricky to craft your attack here, and we'll see that. Anyway, that's people made a big deal about this being a different thing, and it used to confuse me. In fact, it's very much the same as the other ones. So you have something like this. Yeah, the same one. Here you are. So a dynamically generated error message is doing some kind of calculation, which amounts to the same thing as the other kind. Some part of the data that the user sent is rendered on the page and not cleaned up, so we can conclude script tags. All right, let's try a Kahoot, which I should have open over here. There they are. 129S, 12A. Oh, it would only get other users' pages if you stored it on the server, it was stored DOM-based XSS, or if you sent them a special URL for reflected that included it. Exactly the same way the other kinds of cross-site scripting would get to a different user. So the fact that it's DOM-based does not change how you deliver it at all. Yeah, I was sort of baffled by DOM-based cross-site scripting for a while until I realized it's kind of silly to even make a special category for it. It's really pretty much just the same as the other ones. Yeah. All right. I'll give it another few seconds. Ah, good thing. Okay. All right, I guess that's it. All right, so what's the most prevalent vulnerability? Of course, cross-site scripting. All right. All right. So a script in the query string runs on the page. What is that? That's reflected cross-site scripting. You type something into the search box, and when you click search, that script runs on your machine. That's reflected. You just bounce a script off the server back to you. All right, which one can steal session cookies? All right, any form of cross-site scripting can be used to steal session cookies unless they're stored with the HTTP only flag, so they can't be harvested by JavaScript. But the method of delivering the this extra script to your browser does not matter. So which attack can steal all the data in a database? And none of them, of course, that's SQL injection, which is why SQL injection is considered much more serious. SQL injection typically makes it possible to steal the data. Cross-site scripting does not, which is why companies regard it as a lower vulnerability. All right. Right. All right, so I have a few examples from the real world. In 2010, you could submit an issue in Apache, which is like a bug report, and they should fix it, and they were able to inject code there, and the issues are viewed by, of course, administrators who are authorized to modify the code. So they stole the administrator's cookie, and then they were able to add code to the Apache project, and they put a Trojan login form in there. So that's quite a few bad things there. It's cross-site scripting. It's also privilege escalation, and it then becomes a supply chain attack. So, people, he managed to modify what was going on in the Apache supply chain, although they didn't actually modify the Apache software, which they could have, like the SolarWinds attack, but they did manage to steal more information from the administrators. All right. And after they did, that's the point. So this is why the point, cross-site scripting all by itself does not immediately do something horrible, like give you command injection on the server or administrator privileges, but it can be the crack in the door that you come in, which you then make further exploitation steps and end up really doing a lot of harm. That's why it really would be good to patch it, even though by itself, all alone, it may not be that serious. MySpace, Sammy Kamkar, I think he actually got serious legal trouble with this. He made the first really big worm in MySpace. Sammy Kamkar made a MySpace page, a precursor to Facebook, and everybody who viewed that page, it would run a script to make him Sammy's friend and to put a copy of that script on your page, so anybody that viewed your page would run the same script. So in like a couple of hours, he had like millions of friends, the most popular person on MySpace, over 1 million friends within hours. This one was kind of fun. Strong Webmail was one of the first two-factor authentication emails, and this guy was real proud of it and offered a $10,000 prize to anybody that could hack into his mail, and they did it with cross-site scripting and won the $10,000 prize by sending him an email claiming that they had in this PDF is the proof, and in that PDF was a script that stole his session cookies, which they could then use to get in his machine. Twitter had a bunch of these in 2009, cross-site scripting worms. These were all over the place. Happens every now and then. Remember, there was one, well, yeah, Sammy's still around, but yeah, I'm not quite sure. Yeah, he did get some legal trouble for some of these things. He's still around. He makes YouTube videos and everything. He's still a character in the hacking scene. Another one of these I saw recently, I think it was cross-site scripting. There was one that would like brick iPhones, if they saw it, a special name of a wireless network with special characters. Anyway, so here's other things you can do besides just steal a cookie. You can add any kind of code to the page, right? You could add something other than a script. You could add images or code or other content. So, for example, you could put a message that says our business was acquired, go to our new page, to send them to evil.com, and the user would see this as something the developer put there. You could inject actual working functionality. Like here's one. Notice this URL, google.com, and then this long parameter, all full of hex-encoded data. that is this whole fake page. You can put in a whole bunch of HTML, and here they say Google will become a subscription service costing $5 for a year. Fill in this page with your credit card number and everything, and send it somewhere. And all this is going to steal your data and send it to somebody else that is not Google. And it looks good, but all that page is really up here in the URL. So, that is reflected cross-site scripting. Your browser thinks that all this script came from Google, but in fact was right up there in the URL. All right. So if you want to do session hijacking, stealing the session cookies and replaying them, then, it would seem kind of labor intensive to do this one by one, although I suppose you could automate it. But what turns out to be a lot more effective is to do what Sammy Carr did. He did not steal people's cookies and then go one by one into their account and make them his friend. He made a script that would automatically add them to your friend list. Just perform the action right there in your browser with your token. So you make a payload script that will just do this. It will perform whatever action you want to perform automatically and then spread, like a virus, an automatic attack that does something without you having to intervene interactively for each victim. All right, now browsers trust JavaScript cookies from the same website. You can autocomplete things, and if your site is in Internet Explorer's trusted site, you can launch command shell boxes, like wscript.shell and then run calc.exe. So you have command injection in that case. Of course, this is using ActiveX and it's using Internet Explorer. Both of those are pretty old now, although I must say, even one of my major corporate clients still has Internet Explorers on the machines they give me, so I do not think Internet Explorer is gone yet. But I think ActiveX is pretty much gone. But anyway, people keep using old versions of things for a long time. So ActiveX had a lot of powerful methods, which why for security is a lot of reasons why I think people have pretty much quit using it. Yeah, IE works well with SharePoint, and I think IE still has ActiveX in it. I think Edge might not. I'm not really sure of that, but I don't see ActiveX much anymore. I think it's mostly on old websites. Anyway, so you can attack users by logging keystrokes, stealing your browsing history, port scanning the local network, downloading files, installing malware. There's lots of things you can do once I can run a script in your browser. All right, let's try another Kahoot, which is 12B. Now, I've noticed, boy, the jobs I get using SharePoint are miserable. SharePoint does not seem to work very well at all in practice. Yeah, I think your org is wise not to use IE. And I must say, my experience with SharePoint has not made me love it much either. Or for that matter, a central VPN where all the traffic has to go through the home office. That's also a pain point in my corporate work. Although Azure desktops in the cloud are very nice. I'm using those too, and those really work. Yeah. I think you're right, Hema. I think they shouldn't have IE on there. But evidently, they still have some kind of legacy junk that needs IE. There are a lot of corporate products that don't work very well, but I must say Azure really does work. I'm very pleased with that. Yeah, I'm using Azure as my machine for one of my corporate contracts. So they don't give you any software to log in and have you go and use your Azure desktop so that it's secure and air-gapped from everything. Works very nice. All right, let's try this. Night Owl, boy, I don't know Night Owl. Anyway. All right, which one earned a $10,000 prize? Yeah, that was the strong webmail. All right. So which one did Sammy Kamkar do? He did the famous MySpace worm. All right, which one got administrator access? That was Apache. All right, which one is labor intensive, where you have to use cookies one by one? That's session hijacking. All right. All right. TV is won twice. I am assuming that's Jordan. Could be Judy. It's Judy. Okay, good. All right. So let's go on. All right. So how you deliver these things. We talked about this. You could send an email with a link in it to click. I got an email like 2 days ago from, I think it might have been from the college or else it was from Comcast, and it said, "This is not a phishing attack. If you are concerned, click on this link to see a page proving it's not a phishing attack." And I think it actually wasn't a phishing attack. It was just an incredibly misguided attempt to reassure us. Obviously, I didn't click on the link. You know, that's not going to convince anybody that understands the system. Anyway, so you have some kind of link, an instant message, or code posted on a website where you're allowed to put things. These are all ways to deliver the attack. And one cool trick is a watering hole attack. Now, see, the first one, this is what everybody's on the lookout for. You get an email, you have a link, you think that's a suspicious link, and you don't click on it. So what you can do, wait, the first two items, how are they different? Nothing particularly different. These are both essentially the same thing. Yeah, these are just different ways to talk about the same thing. Yeah. This could be, I think what they're referring to is the difference between phishing and spear phishing. Phishing is where you send like a million things, say a generic message like somebody got in your eBay account, and a targeted attack is where you carefully write a custom email to interest your visitors, which has a success rate up to like 20%. This is how professional pen testers do it. You carefully write a message that you know will interest these people, like you've heard rumors the company is being acquired, so you send an email and say, the attached document explains the requirements, like, or you say we're closing a parking lot and you need to buy a new parking pass or something that would interest your viewers. It's much more likely to work. All right, good. Anyway, this is an even sneakier one, and China started this to attack Tibetan political activists. Instead of sending you some kind of message and hoping you're going to be fooled and click on it, they do not send you anything. They just put up a page with content that will interest the targeted people, and then you wait for them to come. So they would put up a page full of information about Tibetan politics with malware on it, and then assume that Tibetan activists will find that page and go to it. So that's a watering hole attack. You poison the watering hole and wait for them to come. All right. Now, reflected and DOM-based XSS, you just have to somehow get them to go to a URL. So you could purchase ad space and put malware in the ad, this is really effective. People often do it with a stolen credit card number, and you can even put up the ad that's innocent and then change it to malware later, and they won't notice for a while, because ads do not load from the main server. You're renting out like a little piece of your page, and that content is coming from somebody else's server, and it's not under your control. You can also use these features where you recommend a page to somebody else, and that can create an email that comes from some other server. Like, you can recommend this page, and I can add script to that email, which actually comes from somebody else's server, but now includes scripts. So stored cross-site scripting, the simplest one is in-band, where there's a page like Facebook where I can type in stuff and it will just appear on the page viewed by other people. Now, Facebook I don't think has cross-site scripting vulnerabilities very often, but MySpace did. And so you just put up things here, put information on the page which is intentionally handed over to other people and includes scripts. You can also put it in logs, put it in files that people are downloading, messages and comments, feedback, and all those things. And then there's out-of-band, things that are not deliberately served as HTML pages, but other things like email that are sent from that server. Anything that lets me put up content which is then redistributed to other people is a possible vector for cross-site scripting attacks. You can chain cross-site scripting. As we talked about, the cross-site scripting itself might not let you do much, but once it lets you get something, steal something like some cookies, and then you can use those to move on to other attacks. For example, if I can put script into a user's display name, then if there's an access control flaw that lets me change other people's names, I could add token stealing script to every username and then get everybody's cookies, and including administrators. So if you want to find these things, what you do, what the most common thing people do, script kiddies do this all the time, you just put something like this in every search engine you see and just on pages, and frequently the script will run and you'll find cross-site scripting. This won't find all cross-site scripting, just the simplest kind. It's like putting apostrophe or 1=1 looking for SQL injection. It'll find the simplest ones, but not all of them. When that attack fails, they might have some attempt to prevent it with a deny list, like removing script tags or some of these characters, and that will stop the simple attack, but you can make crafted attacks like these, where you add an extra space so the script tag is not matched, you mess with the case, you HTML encode some of the characters, you put a script tag inside a script tag, you put a null byte in front so that the processing engine might not process the characters that come after it. All these good old tricks we've talked about before can sneak past that kind of filter. Now, there are attacks that don't simply return the attack string, but take that data and modify it somehow. And in DOM-based cross-site scripting, the data that came from the user is often included inside a tag or something. So it's not just directly displayed on the page. So you have to be a little sneakier. Now, if you want to find these things, put a string in every entry point and then just filter to see if that string comes bouncing back to you anywhere in the response. And then you have to figure out where it appeared. Is it inside a tag, inside a quote, directly visible on the page? And you typically have to tailor your attack to work. And that's what we've been doing in the projects. So you choose a unique string like this, then submit it everywhere, every parameter, everywhere you can put it, and just look at the response to see if that exact string comes back to you anywhere. Then you test each one manually to see if you can sneak in a script tag somehow. And so I got a few demos here. Let's go back to here and look at number 5. All right. So here's one, an image resizer. So I can have height and width of 50%. So I submit that. Now I see a picture of a cat at 50%. But if you view the source, of course, and zoom it in, there you are. There's a source. Height is 50% and width is 50%. And notice I had a space there, and the space went in there. So I control this data, but it's inside an image tag and inside a quote. So if I try the simple cross-site scripting, like this, script alert 1 /script. I don't think it's going to work. And it doesn't work. And the reason it doesn't work is that stuff is here, but it's inside an image tag, and so it doesn't run. So you have to write something more careful to get in there. One thing I could do is put in another quote and an angle bracket to end this. That would be one of the many ways to do it. You have to put in a tag, and here's one solution. Yeah, here's the one where you put in another quote and an end angle bracket. Now you're outside of the image tag, and now the script will run. Now it runs. And you see also I've sort of broken the page. There's some extra junk left over here. So I had some collateral damage with this sloppy attack. But you see, now this image tag ended here, and now my script tag ran, and then I had this leftover stuff, which was no longer correctly accepted by the syntax. But that's one way to get it to run. Another one is to add a event handler inside there, which is what this does. You can just add another tag inside the image tag. And now, when I submit it, nothing happens, but when I click it, the pop-up happens, because I've now created valid code with an event handler. So this cat image has a height and a width and an event handler, like onClick. If you add another scare quote, yeah, I think that's probably an old comment. Yeah, that's right. So there's, that's the point. When I say you have to customize your attack, you'll need a few more punctuation marks and so on if the data you're putting in is added in an unexpected place. All right. Number 6 is a JavaScript string. Let's try that. If I go back to here, here's number 6. So I have variable A. Let's put in a 1 and submit. Okay, and now if I view page source, this is where it goes A equals 1. So I control that. And it's inside a script tag and inside quotes again. So once again, I just have to complete the syntax. So there are many ways to do it. One way to do it is this one. Now I run the script, and if you view the source, what I did was insert all of that. So now A is empty, semicolon, alert 1, semicolon, var B equals the other empty. Now I've made 3 JavaScript commands instead of the one that was supposed to be there. And do these variables persist? Yes, they'll persist as long as this page is open, yeah. And you could see that if you do tools, developer tools, down here the browser console, I should be able to do, let's see, that's not the right, I've got to have the JavaScript console. Let me try it again. Tools, view, developer tools, tools, browser tools, web developer tools, here we go. And now I could say alert A. Oh, A is not defined. Well, I thought A would persist, but maybe I'm wrong. That's interesting. Well, I think the variable will. Let's try alert B. In fact, let's try console. It'd be better. Console log B. Yeah, and it doesn't even want to take the B because it doesn't think there is any B. Yep, there is, B is not defined. Of course, setting it to something like that might not count, an empty string. Let me try setting it to a real value. Let's go back to this one, and let's put in a value of 1 there and a value of 2 there. Now they'll be setting A to 1 and B to 2. The script runs, and now if I do tools, browser tools, web developer tools, now I should be able to do document .log a, and it's still a is, wait, console.log, pardon me, console. And now is, okay, now it persists. Yep, console.log A and B. So yeah, they do persist. A and B are there. They'll persist on that page until you reload the page. Good. All right. And let's see what we got here. That was 5, that was 6. 7 is an attribute containing a URL. These are all very similar. So here you get to put up a URL like ccsf.edu, and when you submit, it puts up a link that lets you click and go there. So if you view the source again, see it ahref, click here, and what I control is what's inside there. So the other tricks we've used before would work, where you add an extra quote, but you could also just put JavaScript directly in there, like this, JavaScript : instead of HTTP : That is a valid URL. In fact, you can do that up here. You can put JavaScript : up there. It doesn't seem to, well, you used to be able to put it up there. Anyway, you can certainly put it inside a page. There, JavaScript alert. Now when you submit it, now when I click, the alert comes up. So it's valid to say JavaScript like that in a URL. All right, and I think there was another way to do this. Yeah, this is the old-fashioned one, where you just add the missing quote and then put in an event handler. So this sort of combines two techniques. Now when I click, this pops up and it goes to City College. And if I view the source, you'll see both of those things in there. It's going to go to City College, and it's also going to run this JavaScript when you click on there. All right, and might as well just do this one while we're here. If you're going to block script tags, if I try to do this, script alert1 script, and then do submit, it doesn't work. It detected the script tag, you're an evil hacker, you don't get the message. So you have to sneak in the script tags. And here's one. You can use an object tag with data, and the data includes the script tag, and this passes the test. Oh, I don't know why it doesn't remove them from inside there, but in fact, because it's interpreted as data, no, that one it blocked. Okay, because script is literally in there. Good, I feel better. This one, however, has base 64 encoded the data. So it's base 64 encoded, so the literal string script does not appear in there. But it will be interpreted as script, and now it runs. And by the way, you probably know the same thing is true of PowerShell. PowerShell in Windows will accept base 64 for commands, which is, again, very handy for people who want to sneak things past filters. And one of the many reasons why deny list filters are not a strong defense, because there's so many ways to sneak things by. And here's another one, which even also works in Chrome. Chrome blocks a lot of these. Firefox is the easiest to exploit. It's a simpler browser. It doesn't have as many defenses. Anyway, I think we've been through that. All right, so defensive filters. You may have a web application firewall that's just blocking the data before it even gets to the server. The server may accept your input, but do sanitization, where it tries to remove the bad part and continue to use the rest, or it truncates your attack string to a fixed maximum length. Those are common types of defense filters. So if you want to beat signature-based filters, like the one we just saw where it said you're an evil hacker, it detected your dangerous request, then you just need to scramble the string. So it's looking for something like script, so you have to write it, and you have to sneak it in ways like this. This hides it inside a data object, which might fool it. This base 64 encodes it, and so on. All right, we saw that one. you can run event handlers. All these will automatically run. On ready state change, run a script. You can put it inside many tags. On error, on ready state change, there's on activate, on focus in, on before reactivate. There's a bunch of these event handlers. There's one on load we've used before that will trigger when you load a page, even if the user doesn't point to it or click to it. There's a thing called autofocus in HTML5 and on blur and on scroll that will run these scripts. You can put it in closing tags. To use these, you would need to know the DOM structure. No, you wouldn't. You don't really need to know, like especially these ones back here, just run when the page loads. So, but I think you would have to know, just if you can get these tags inside a tag. So you would have to have the ability to inject into a tag. Or you could just inject this whole tag. So no, I don't think you need to know the DOM structure in any detail, not for these. These don't require reading data from them. Wouldn't these tags need to be? No, they would not need to be in a certain spot on the page. They could be anywhere on the page. Only if you wanted to make the people click on them or something. There is the issue that we hit in a previous class, or the class before, where if you're trying to do something like steal data from the page, and you put this before that data is already on the page, then that data might not exist yet. And then you'd have to inject a more complicated script like we did, where it reloads the page. Yeah, can the page have more than one body tag? Well, I wouldn't try adding a second body tag. You're right about that, although you probably can get away with it in some browsers. That would be an error, you're right. Yeah, I wouldn't. Yeah, if you wanted to put these in a body tag, you'd have to have the ability to inject a body tag or to comment out the previous body tag. Yeah, it would be a little unusual to be able to do that. You're right. Although I think you can have more than one body tag, and I don't know which one takes effect depending on the browser. Remember, one great thing about HTML is your HTML can have errors in it, and your browser will still render it. That's one of the fundamental reasons this all happens. Yeah. Well, you can have anything, and your browser will try to make sense of it. Many pages are written with bad HTML. So, and there's some HTML tags, video tags, are some new HTML5 tags you can try. There are script pseudo protocols, like say JavaScript : wherever you'd put in a URL. IE used to allow the VBS for Visual Basic scripting. I think that's still around, even in Windows 10. It's getting really old. HTML5 has a few new ways to put in JavaScript. And IE7 used to allow you to put it in a style you could put in JavaScript. Later IE versions let you do it too, inside a style. And if you want to obfuscate this attack, align error equals alert1, you could change the case. You can insert null bytes is another way to do it, which would not prevent the HTML renderer from seeing it, but it probably would prevent the web application firewall in front of it from seeing it, because the firewall is probably written in C. That's how inserted null bytes work. Code written in C, it'll terminate the string, and so typically your web application firewall is written in C for performance to make it fast, and therefore it will be fooled even though the web server behind it will still let that tag through. You can have invalid tags, like an X tag that doesn't exist. This is another flaw with HTML. HTML has a lot of versions, and you can have new versions, and so if your browser hits a tag it doesn't recognize, it says, oh, maybe I'm out of date. And that tag just doesn't apply, so it won't give you an error message or stop. It will just kind of ignore it. But if there's an event handler in there, then it'll probably let it run. It won't know what the X means, but it'll let the rest of it run, because remember what we did last time? There are multiple passes through your source code. First it does a pass trying to find the JavaScript and pass it to a different parser. Then it renders the rest. So even though the X is invalid, the JavaScript is valid, which is the kind of madness you get in web browsers, where you have multiple languages mixed in the same file. All right, if you can change the base href tag, then that will be the base for all URLs, so when they try to load a script, they'll in fact be loading from a different server. That would be nice. You can put in a space following the name of the tag. If you don't want to put if it's looking for bad image tags, you can put something other than a space to separate the name of the tag from the parameter after it, and it'll accept it. So these, again, may very well fool a filtering system, but it will still be accepted by a browser. You can put null bytes in the attribute name, so the on error has a null byte in it. You can use backticks instead of normal apostrophes as delimiters, which may very well confuse the filtering system. So if it doesn't know that the backtick works as an attribute delimiter, it will interpret this whole thing as one attribute, not understanding that this terminates the source and this is the beginning of a separate event handler. You can put in null characters or HTML encode characters to sneak things in. Here's a script alert, something where quite a few characters are just HTML encoded as numbers in the middle to confuse the filtering system. You can use HTML encoding to encode any part of it with various ways. You can use double encoding, because some applications run it through 2 layers of URL decoding. So you can use %25.3 and that 3C. The %25 is the code for %. That'll turn into %3C, and when decoded again, that'll turn into the less than sign. So, and it may be that your filtering system only does 1 layer of encoding, but your actual application does 2 layers. So again, your filter thinks there's no less than sign in there, but the app does find a less than sign in there. Sometimes you can use goofy characters like these. Instead of proper angle brackets, you can use this funny foreign double angle bracket, and some app frameworks will translate these unusual characters to the nearest ASCII equivalent, so that would be accepted. Sometimes browsers tolerate extra brackets, which will probably foul up the filter. Firefox will even let you put the wrong direction of bracket here to close the script tag. There's a web developer add-on you can put in your Firefox, which will let you see the actual code that Firefox tries to clean up. This is the fundamental reason why all these stupid things work, is because your web browser is like a television. You're trying to see web pages. And even if the developer was sloppy and wrote a sloppy web page, you would still like to see it. So instead of just giving up when it finds an error, it tries to guess what the page should have been and shows you that. And so here you can see what it did to try to clean up the source. And of course, that means everything you view in a web browser is in fact going through this sanitization, where it takes code and modifies it to try to clean it up by guessing how to clean up the errors. You can go to different character sets. You can specify, there's US ASCII is the most common one we talk about. There's the 16-bit encoding that Microsoft uses internally, where you put a null byte after each ASCII character. So you can, in fact, encode some foreign characters, but it's a different pattern of bits required to encode characters. So you can set the browser in your web page. You can tell it what character set you're using. There's even a character set developed for Japanese characters, which always uses 16-bit encoding. So what you can do is, if I, for example, have the ability to input here and input here, and I want to deal with that quote, I could input F0, which begins a 16-byte Japanese character, and that will eat the quote here, interpreting it as the second byte of that 16-byte character. So this quote will vanish. That's one way to chew a character out of the source code the developer put there. All right. And so you can escape your JavaScript by using Unicode. This \U006C is an L, so it's ALERT1. The L is now turned into this Unicode thing. You can use eval to evaluate these things. You can add extra escape characters, escape normal letters that don't need to be escaped, but it won't hurt anything, and it may confuse the filter. just many of these tricks. A to B is ASCII to binary. It takes base 64 encoded data and turns it into binary. That's what it's for. B to A turns it back. So this lets you base 64 encode your stuff. So here you can use A to B here, where it takes this ASCII, which is base 64, turns it into binary, which could be anything, and of course it's going to be a script, and then evaluates it, and now you don't see the script in your filter. And so there's, you can do replace to put eval in there. You can, if you don't want to have document.cookie, you can use these alternative ways to refer. This is the document object model, to refer to the cookie in the document object model. There's just a lot of dirty tricks. And there's too many things to remember. You just sort of get the general awareness of them, and you'll see them in the projects. All right, I don't think I'll bother with this one live, but you see there's various ways to sneak things in. This is one that uses eval. So you've got a function, and it's going to do this. Replace something by eval. Let's see if I understand how this works. Get element by ID demo. Okay, this is going to get the demo up there, the inner HTML, and then replace star by eval, which I think is just the beginning of it by eval. I'm having a little too much bother understanding that one. I'm not going to struggle with it tonight. All right. Anyway, this is an E for alert. The backslash is in URL encoded, so this mess is alert 1. All right, and you could HTML encode the whole thing, which is why, trying to make a list of bad characters to block is kind of a bit of madness. All right. Let me just take a look here. VB script is pretty much gone. So another thing is, of course, if you can encode characters, like take less than and greater than, and HTML encode them, which is a good thing to do, then they will appear on the page, but they will not be meta characters, so they won't run scripts. So you can try to make an attack string without using less than or greater than. So for one thing, you might already be injecting inside a script, then you don't need those tags. Or you sneak in the script using any of these techniques we talked about, like null bytes or encoding it in a strange way. If they're trying to remove script, they might not be doing it very well. Like if you put in 2 of them, it might only remove one of them. If you put one script inside another script, it might remove the first one, but not notice that it's created another one. All right. If you inject into an event handler, then you can just put the alert into there, and it will be inside here, and it may ignore the fact that it's inside a variable and run. If you have length limits, if you can only put in a short injection, you can make shorter attacks. This will send cookies to a server with hostname A. This is if you can get a file share on a local machine named A, this would be one way to do it. This will execute script from the server with hostname A. There are online tools to make your JavaScript smaller. This script is already smaller. The only thing you could do is remove the semicolon, which didn't even do that. But you can put complicated JavaScript. Sometimes you can pack it smaller with tools like this. And sometimes you can use multiple injection points. So if I can inject a little bit of code here at page ID and a little bit of code here, I can combine 2 injections. So it returns 3 hidden fields on the page. So what I do is, in the page ID, I inject a script and an opening comment tag. In the seed, I inject a closing comment tag and the alert. And in the third one, I inject the slash script. So the end result is this. The bold is all that takes effect. The rest of it is commented, alert document cookie / script. So by injecting comment tags, I've strung together these short fields to make a longer script. And that may look familiar because that's kind of what we did for XML injection a couple lectures ago. and for SOAP injection. And to convert reflected cross-site scripting to document object model, you can inject a script that harvests stuff from the URL. This one here will pick the hash from the URL, and the hash is the part after the pound at the end of a URL. Some URLs have something at the pound, so you can write a script that harvests data elsewhere to put it in. And they might do that to beat a length limit. So even if you can only inject this relatively short script, you can then put a whole lot of extra data up in the URL and harvest it here. So here's one example. I do a script, an alert long script here. So I put in the message here, then I put a pound, and I put a longer script there. And when it runs, this message will harvest that. And here's a shorter message that would work most of the time. This one is kind of nuts. You put in a #0a here, which is a line feed, and what happens is you unescape the entire URL. So you run the entire URL as a JavaScript. But when you do, HTTP : is interpreted as a label. The // is interpreted as starting a JavaScript comment, which goes until the 0a, and then the script runs here. So this is a bizarre recursive attack where you put something in the URL and then you execute that entire URL as script. Anyway, there's a lot of techniques. Let's try the last Kahoot, and then we'll take a break before the demos. 12C. All right, I guess that's it. All right, so which attack puts up a malicious page and waits for targets to visit it naturally? That's the watering hole attack. You just try to make an attractive page that they will find. All right, what attack injects the first part of a 16-bit character to remove the next character? Yeah, that's the Shift.js, the Japanese encoding. I've seen a very good video about the person who developed, I think, Chinese ASCII. Getting Japanese and Chinese into computer-readable code was, in fact, a very difficult job. Anyway, all right, what character might cause a filter to stop working, allowing script through? Yep, the null byte will be interpreted as the end of a string by C-based code. All right, what function decodes script written in base 64? It's easy to get it backwards. ASCII to binary. The original purpose of base 64 was to send binary data through email. So you would take binary and convert it into base 64, which was guaranteed to be ASCII, and then at the other end you would decode it with UU encode and UU decode to turn it back into its original binary content. Anyway. All right. All right. Good.